One. Thank you so much for joining me today. If you're watching this, you're watching the recording. We haven't got anybody in on the live stream yet. That's okay. They'll be just jumping in here in a few seconds. Remember, if there's anything specific you want to see on these live streams, down in the description area is my email address, lars.christensen@autodesk.com. And shoot me an email if there's anything specific you would like to see on these live streams. See, well, we got the first people in here. Good morning to Seth. Absolutely awesome that you will join today. A couple of things just to quickly just take care of. So these live streams are really just my attempt to kind of like try to create maybe a little bit more value for you guys. It's like 15, 20 minute long, just kind of like trying to add a little bit in there that hopefully you find helpful. Today, we're going to talk about file formats. And this is actually something that when I kind of like got this figured out and straightened out in my head, it really helped me a lot when it comes to IGES, STEP, what should you use, what is your preference, and all that stuff. But before we jump into that, just one quick thing we got to do. I got to thank Paul, because Paul posted in yesterday's live stream, number 20, down in the comment area, in regards to people complaining, people not complaining, people are awesome, you guys are awesome, are telling me that they're not getting notifications about these live streams, and that's a shame, right? Great thing is, of course, they're recorded, but if you jump into YouTube, and I jump in here to Tom's from Inspiration Metalworks site. He's a great guy. You should definitely follow him. But what Paul pointed out is that over here, when you go to a YouTube channel, you can be subscribed to it. But of course, if you are subscribed to my channel, thank you so much. But there's also this notification bell over here. And if you click on that, you can actually check, send me all notifications for this channel. If you click save, you'll actually see you get kind of like a couple of lines next to the bell over here. And that is supposedly, as far as I understand, and what Tom explained, is this is the way to get notified about these live streams. I hope. Give it a shot. Let me know, how this works. Again, this is kind of like a YouTube thing, not too much I guess I can control there. But yeah, thank you so much. We got 26 people already jumping in here. I always start a few minutes early when these are scheduled, and that's what I'm trying to do this week. Tomorrow's live stream, now we're talking about notifications and scheduling, is at 2 p.m. Eastern. Eastern Standard Time is the same time as New York City, just in case you're somewhere else in the world, at 2 p.m. And tomorrow is about CAM. So if you're not interested in CAM, just don't bother, right? It'll take the day off. It's Friday. We're going to talk about a little bit of 4-axis wrap inside of Fusion 360. But just quickly look in here in the live stream in here. So I said we got Seth in here. He's a great guy. If you ever go out to the Fusion forum, Seth is the man. We got Adam. We got Bob. Good morning, everybody. We got everybody. We got people from Denmark. We got Carl is in here, Tom, everybody. I am so happy that you guys took the time out to join this live stream. So, like I said, let's jump into it, and I'll get back to the chat a little bit later. Let's talk about, file formats, and let's talk a little bit about solids and how kind of like this works. And like I said in the beginning, this was something that when I kind of got this figured out, it just made it a little bit easier for me. So I hope that you get something out of it. If you don't, there's the thumb up and down. Like if you like what you see in these live streams, do this. If you don't, then do this, right? Okay, let's jump into to Fusion here. So Fusion 360 is what we call a solid modeler. It's creating what is really a watertight model. Now, if we go in and we say that if we wanted to not a new project. If we go into any of these, really doesn't matter. If you go into upload inside of Fusion, and you click here, you get like a whole, Cheesecake Factory long menu of all different file systems that you can import in. And some of them are 2D. So for example, AutoCAD DWG, like without aging myself here, like when I started in the industry, AutoCAD was kind of like just booming out. I started at version 2.4. Now you can figure out how old I am. But that was all 2D, right? You drew almost like on a piece of paper. And so some of the things you can import in here, DXF, that's all kind of like a 2D environment. But then you're getting into the solid models in here. And of course, that is like IGES STEP, but it's also like if you SolidWorks files, if you bring in Pro Engineer and things like that. Now, if we go back into Fusion here, so solid models is kind of like what you want to end up with. I got an email the other day from a guy who said that he imported a file and it was all surfaces, and it kind of like slowed Fusion down, but as soon as he got it all stitched into a solid, then it seemed like that Fusion was doing great. Why is that? Well, first of all, when you're bringing in all these different surface models, all different kind of like sheets, but when you get it into a solid, it becomes a watertight model. It's almost, think about like a bottle of water, like it's watertight, you can flip it up and down. And the great thing about a solid is that the computer knows that there's something there. You can actually get, weight, mass, kind of things. When you do an extrude through something, it will actually, make the indent and things like that. So solid is where you want it up. Now, what is interesting though, is we go into Fusion here. There is a patch area inside of Fusion. What is surfaces. Now, so I talked about how we started out with AutoCAD, what was all like 2D lines flat on a sheet. Then in the technology, we started doing surfaces. And what surfaces really is just a non-thick blanket. Like almost like, think about it like a sheet or a blanket or a piece of paper kind of thing. And that was kind of like prehistoric for solids. Now today, pads or surfaces are really used a lot if you're doing really complex shape. Of course, inside of Fusion, we also have the sculpting environment here that kind of with T-splines that kind of like makes that a lot easier, honestly, to work with. But just to show you kind of like, if we're going to the patch area, let me start a sketch in here. And I'm just going to sketch here on one of the sides, hit my S key, and I'm just going to do the good old 3x3 inch rectangle here. Now, if in the patch with surfaces, if I go in here and I extrude this up here, I'm just going to make that also 3 inches. So now we kind of like got this cube. You will see these walls here have no thickness to them. This is a surface wall. And if we click over in the bodies folder, you will see that we get kind of like this body of surfaces. Now, if I go in and I do the patch, so I can put like a lid on this, do one there, you will see now I get another surface over here. Now it's just an open box. Let me right click and repeat patch and do another one on top here. And now we kind of like got a closed cube, but it is all just surfaces in here. There is nothing inside of, if I do like a section analysis, there's nothing in here, right? This is an empty kind of box just made up of those walls. Now, so many times when you're working with surfaces, you're building up your complex shape. Think like car, like you look at your dashboard in your car. Most dashboards have like, except if it's maybe a Jeep, most dashboards are like very curvy shape, and you might build that up with surfaces. But what you then do in the end is you stitch it together into a solid. So if I select all these surfaces and I use the stitch command, it now, you will see, becomes a body in here. So now it's a surface, a solid body, just like we normally use. Matter of fact, if you look down in the history tree down here, you will see sketch. That was our extrusion of the 4 walls. We patched the 2 tops, and then we stitched again. Well, all what you see here on the screen is actually what's happening in the background when you're doing a standard extrude inside of Fusion. If I go in here and say new design, open up a new sketch, and do the same as I just did before, sketch a rectangle 3 by 3, and if I then hit the Q command, right, for push-pull, and I hit in 3 inches, what you see here with the sketch and this joint is the exact same thing you see in here. This is really what the software is doing in the background. It's kind of like in the background, the software, when you use the push-pull, it's kind of like saying, all right, that's 4 walls up, and then let me cap it, and then let me make it into a watertight solid. So I hope that kind of like is a good thing to know, like kind of like the steps from 2D into surfaces. And surfaces is still used today, like I said, if you're making complex shape. Now you might get surfaces when you are importing into Fusion from another software, and that's because if there's a tiny little gap in that model when it gets brought into Fusion, then Fusion will not close up that gap, and it will bring it in as a surface model. And if you get a surface model in, it's really an indication to you that, hey, you might need to go in and fix a couple of things, and that's not uncommon. And that's also why that patch area or the patch workspace exists inside of Fusion 360, is because you can go in and you can kind of like fix things. So I hope that that's kind of like helpful. So again, if you're bringing a model in and it comes in all the surfaces, it could just be the smallest little area where you just need to, fix a little gap. It's not watertight. Water would come out of it. And as soon as you've done that, you stitch it all together, bang, then you got a solid. So I have tried where I've imported a model and there was just, hundreds and hundreds of surfaces, and you're like, oh my goodness, this is like a nightmare. But as soon as you start kind of like diving it down, maybe turning surfaces on and off, and you're finding that one area where things are a little screwy. So hope that is kind of helpful. Now, talking about files and file types, let me just open up. You wouldn't believe it, but I actually have a little bit of a PowerPoint. Now this is gonna be boring, isn't it? No, I wanted to talk a little bit about the files that you can bring into Fusion and kind of like how it works, because I think that this, like I said, when I figured this out, that made my life a lot easier. Because what are you supposed to bring into Fusion out of all these different things? If somebody comes and says, hey, I got a file you got to work with, what should you ask for, and why should you ask for the file? So file favorites, it should probably be called Lars' file favorites. Like I said in the title, this is free. You can do whatever works the best for you. But my third favorite that I would ask for, if somebody comes and says, hey, Lars, I got to send you a file, what format do you take? That would be, I got to click on the right screen here. That would be an IGES file. Sorry about that. So IGES, and now I'm going to take a sip of coffee here, and then I'm going to give you a little bit of history of it that you might find interesting. So IGES, it was developed back in 1980, what is a heck of a long time ago if you think about it. It was developed by the U.S. Air Force, who dragged in some of the major companies like GE, Xerox, and a couple of other companies to help them come up with a neutral format, so when they were sharing these solid files between systems, that they had a neutral format that they could share between them. So like, if you're getting a file from SolidWorks or from Pro Engineer or somewhere else, and you could make it a neutral format that any of them could open up. So they developed this IGES file format. Now, the interesting thing about IGES is that there have not been any development done on IGES since 1994. Whew, That's a long time. 1994. They have not touched IGES in the development stages since then. But it's still actually the most used of the neutral formats there is. The second one is STEP files. That is my second favorite. And STEP files was actually developed in 1984. So 4 years after IGES was developed. And STEP is an IGES format. It was actually created to replace IGES. And originally the idea was to create one type of STEP file that just could kind of like do better job than IGES does. But what it actually ended up being, it became a little complicated. And today there's a lot of different STEP formats. There's different versions of it. So there's a 2.13, 2.14, but it's both CAD related. You shouldn't really worry about what version you get. And I think that the last one was 2.42, and that was like 3 or 4 years ago they came out with that. So they're still developing on STEP. And then my favorite, of course, is the Autodesk, what is called the archive file. So that is the Fusion file. So if somebody comes to me and says, hey, I gotta call a customer and they want to know what kind of file format you can use, this would be the 3 formats that I would ask for. And actually, what I have done in the past when I was in industry was that if I had to send somebody else a file, I would actually send them all these 3. So they could pick which one they wanted to use. And I've actually seen, like with IGES and STEP, I've actually seen, sometimes better results coming with IGES than you get with STEP. Because what happens in the background when you're bringing in a file into your system, either if it's a SolidWorks file or if it's a STEP on IGES, you bring that into Fusion, it goes through a conversion, right? It's a little bit like converting, I don't know, Danish to like Chinese. There could be some errors going on. So you should definitely, whenever you receive a file from a customer that is not the native Fusion file, I would say you should definitely just spend 2 minutes just investigating it, just to make sure that you got the right thing. Now, funny thing is, if you open up STEP and IGES in a text file kind of thing, IGES was actually generated on the old punch card data. So you should actually theoretically be able to sit down with a pencil and piece of paper and follow the coordinates of an IGES file, and you should be able to kind of like draw up what the IGES file is with the coordinates. The STEP file is a little bit more like an HTML type of file. It actually contains a lot of things in here, like a color can be contained in here, and actually also some metadata, but none of the CAD companies, as far as I know, are utilizing any of that inside of a STEP file. All right, just ready to wrap this up. Just the last thing here, what I think is kind of like put the icing on the cake. So if we're looking at a solid CAD file, what is a solid CAD file? Well, it's kind of driven by a kernel inside of your software. There's this math kernel that kind of like runs things in the background. That math kernel is looking for geometry. Now, when we're talking about geometry, we're not like talking like lines and arcs. We're talking more like edges and points and vertices. And then this kernel then has something called topology, what means that it takes all these edges and vertices and it figures out how it kind of fits together, how it's kind of like spliced together in there. Then there's something, of course, called display data. So this is how the kernel now is going to take this topology, this geometry, and how is it going to display it on your screen. Then, of course, also you have like your data, your feature tree in there. So like the vertical one that has all the different parts and stuff, but also the one, of course, down in the bottom that I didn't show on this screenshot here. It also contains things like metadata, right? So like the mass, and it can have like colors, and you have assigned different appearances to the model. And then lastly, if it's like an assembly, you can have a bunch of joints in there, right? Like how is everything, if it's an assembly, how is everything kind of like made it together? What is important to know is that when you import and export out of a CAD software, it's only the kernel, the green portion, that goes in and out. That means that you're losing the other things. This is the only thing that can come in and out of the CAD system. So that is why that if you're opening up a format, some other format, you're bringing it in, you will not get those features, the feature history in there. And that's also why you will not get like the metadata and so forth. That is because that when you are importing and exporting a CAD file, that CAD kernel is only holding on to the geometry, topology, and display data. The rest of the things in here, the joints, metadata, and feature history, they are not part of that. So it's important to know that when you're going in and you're trying to import into Fusion, or you're deciding to export out of Fusion to, this is kind of like the import area right here, right? That it's important to know that there are certain file formats that, of course, are your preferences. So, of course, a Fusion file is a preference, because if you're opening up somebody else's Fusion file, there's no conversion, right? It's just data dumping in and out. Like if I'm saving out a Fusion file and I give it to you, then there's no translation, conversion, or anything. It's just data in and out. But with these other ones like IGES and like with STEP, or even like if you're bringing in something like SolidWorks, Pro Engineer, or CATIA, something else, it's gotta go through these calculations. So that was really what I was kind of wanted to show today. I hope that made a little bit of sense. Kind of like get an idea about how surface modeling works, how you kind of like can work with these sheets or blankets, and then you can stitch it together to a solid. And then, of course, these solid files, kind of like how they build up, kind of like maybe making it a little bit easier to understand that when you're handing somebody a file or you're receiving a file, why things are not always the way that you maybe thought they should be. Of course, there's always a decent explanation. Again, I want to thank Paul for the notification that you should go out and hit the little bell next to the subscriber button on the channel. Then you should, as far as I know, get notified about these live streams. The next live stream is tomorrow. It will be at 2 p.m. in the afternoon Eastern time, and it will be on cam. Now, if you skip tomorrow's, just be aware of that next week I'm on vacation again. It is the 4th July week, and we are shut down, so there will not be any live streams next week, but planning on taking them up the week after. All right, let me just check in here. I can see that we got you got 53 people in here, which is awesome. Thank you so much for taking the time to jump in here. So one question here from Phil, just wondering, the best standard might be STEP. Well, yes and no. First of all, being in the industry for a long time, seems like people always have a favorite, right? Like you have used a certain file format like IGES, and you got better result than STEP. And I have actually seen both of them perform differently. So like I said earlier, that sometimes I have actually sent people all three formats. So the format that I'm working in my CAD system, in this case would be Fusion. It would be an IGES and a STEP, and send that to the customer or or whoever's going to work with your vendor, whoever. Then they can pick which one they want to work with, which one comes in the best. What I have seen is like there was one time I had a part that had some very thin slivers to it, and the STEP file actually closed them up. So I tried to repair it. It saw it as bad geometry, tried to repair it, where the IGES did not. So that's kind of like where you got to use your best judgment. All right, guys, I'm going to do as I normally do. If you're watching the recording, thank you so much for taking the time to join it. Don't forget my email address is down in the description area, lars.christensen@autodesk.com. There's also the link to the free CNC Handbook. Don't forget about the free CNC Handbook. If you don't have it, check it out. It's completely free, no spam email or anything, and share it to somebody. Maybe you know somebody who would like to get that. And I'm gonna end the broadcast. I'm gonna go into the chat and just say hi to everybody in the live stream. And until tomorrow, have an awesome day. Thank you.